Welcome everyone. So my name is PJ and I'm going to be talking about Go with React. Having said that, I'm going to be trying a new accent as well, so I'm going to be working on a special accent, so just bear with me. It's because I'm an aspiring actor. So, okay. I work for a company called OpenSimSim, and we are hiring at the moment. We're looking for Golang developers. The email address there is where you can send CVs to. Okay, this talk is not about backend development. Okay, so I know a lot of you guys are backend developers. This is not about backend development, it's about front-end development. It's using a package called Gopher.js, which is a Go to JavaScript transpiler, similar to TypeScript. The only assumption that I'm going to make here is that you know some basic jQuery and some basic JavaScript. So, as I mentioned, Gopher.js is a transpiler that is very similar to TypeScript. So obviously, as some of you might not know, TypeScript converts TypeScript, which is an enhanced version of JavaScript, to standard ES5 JavaScript that runs on any standard browser. There are very good reasons for not using JavaScript. If you ask any professional front-end developer, absolutely no one will be using standard stock JavaScript anymore. They're all going to be using TypeScript. They might use JavaScript with Flow, which is designed by Facebook. Perhaps even Dart, which is developed by Google. Some of the advantages of these new alternatives to JavaScript is that everyone knows that there is some serious benefit to strongly typed languages. Stock JavaScript is not one of them. As you probably know, Go is one of them. So there are some advantages. Another advantage of the Gopher.js project is that to some extent you can actually share your code, most likely your models, for example. So if you're creating a REST API and your front end has to communicate with your back end, you can reuse your actual structs that you're going to use for your models. So that's another advantage. Another advantage is you can actually use the same code base and actually compile it as a standalone Go application or as a JavaScript application using Gopher.js, and all your code will work, generally speaking, including Go routines. Even though JavaScript is single-threaded, so you're not in practice you're not actually going to be able to, behind the scenes, it's not actually going to use concurrency, but your programs will work as you expect. Another advantage is every single person knows that every front-end developer's job, as they're currently programming, is in danger, because the future is WebAssembly, which is basically going to treat the web browser as it's basically going to treat the web browser as a sandbox virtual machine that's going to actually run compiled code, and that's called WebAssembly. Go and a couple of other languages such as Rust are ideally placed to be able to produce WebAssembly binaries. And one of the advantages of Gopher.js is you can very, very easily convert your code with minimal changes to make it compatible with WebAssembly. There are some drawbacks with Gopher.js. The main drawback is the generated JavaScript files, even when you apply the minimized flag to the Gopher.js compiler, it is very, very big, very large file sizes. There are some tricks you can use to minimize the file size. One is to avoid using the Func package, avoid using a net HTTP package. But that's not very easy to do, because if you want to use third-party libraries, the chances are they're going to use those packages, so you got to be very careful. There is another trick you can use, and it's to use the JS Go project, which is basically a CDN that stores in the cloud the actual standard library. And you can use the JS Code project. Now, as I mentioned, it generates very, very large file sizes. Therefore, it is not a good idea to use it as a web for making websites. Maybe you can do it if you've got absolutely no choice, but if you have a choice, do not use it. But there are two places, in my opinion, where Go4JS really shines. One is if you want to make a desktop application. So you probably, as a Golang developer, you probably dreamt up some desktop application and realized that Go is not very, very good for desktop development. There are a couple of projects, however. One is Electron. Put your hands up if you know of Electron. Does anyone know what Electron is? Okay, about a third of the group, half of the group knows what Electron is. Electron is basically developed by GitHub. It's a very, very comprehensive package that allows you to make full-featured desktop applications that are cross-platform, Mac, Windows, Linux, in JavaScript and Node.js. Due to the fact that it's JavaScript and Node.js, you can use the Go4JS project to compile your Go code and make Electron applications. One of the reasons why Go4JS, which generates very large file sizes, is fine for desktop applications is because Electron is already very large. So it doesn't matter if your JavaScript file, which is going to be a couple of megs, it's not going to make a big difference. There are a couple of other Go projects as well that you can use for desktop applications. So I've mentioned two there. In the end of the day, they all work in the same principle, which is using Chromium, which is it's a web browser. It's like a library that is a web browser behind the scenes, and it allows you to make user interfaces that look and feel like native applications, but they're really just websites, and hence why Go4JS is a very useful tool. The other great benefit of Go4JS is for prototyping and demonstration. So if you're a backend developer and you've got some really cool feature that you've made and you want to show it to your boss. My accent's gone. Let me just take a drink. It disappeared on me. Shit. So, for example, let's say you are a backend developer and you have created some really cool little project that you would like your company to use, but it's very experimental, it's very much a prototype, in which case what you can do is, and you don't have access to front-end developers to help make it realized, in that case you can do it yourself. You can use your Go skills and you can create your prototype, and then you can show it off to your managers, and they're able to actually see what you're trying to do. So the other part of this presentation is React. Now, who here has some exposure to React? They know the benefit. Okay, so very few, in fact. I expected a bit more, but that's not the case. That's fine. So as I said, the assumption is that you guys know basic JavaScript, you know basic jQuery, but the reality is professional front-end developers don't use jQuery anymore because when your project gets very big, it gets very hard to scale the complexity. You know, when you're adding event listeners, you're adding click handlers here and there for all these different objects, it becomes spaghetti code very, very easily. Therefore, you need some newer technology out there, such as Vue.js, which I'm not going to talk about, or React. One of the benefits of React, which is created by Facebook, is it's got a virtual DOM, which is essentially what Facebook realized was that they can actually increase the performance of their websites by making a comparison. So every time you make a change to your website, the website DOM, every time you make a change, before you actually ask the browser to make a change, it'll do a comparison with the current state of the browser's DOM and the virtual state, and it'll only make the minimum changes required. It'll only make the minimum changes required to the actual DOM, and therefore increase performance. There are three, in my opinion, there are three concepts to React, which I will demonstrate in my live demonstration. There are only three concepts to React that you need to understand 85% of React. Just three. Concept one is, so this might be a bit different for people coming from a jQuery background, but concept one is you let React manage a particular item in the DOM. A particular element in the DOM, you let React manage it and you don't try and do anything to it after that point, which I'll explain further in a few slides later. Number two is the second fundamental concept in React is you create a rich user interface by creating a component which is like a class. Now, class can actually, it's like a blueprint. It's not actually in memory. It's not actually in the DOM, but it's a blueprint that you use. It's like essentially an architectural design for how this component should behave, and then when it actually gets created in the DOM, then it will behave as you expected. But the component itself is not actually anything real. It's basically like a class in an object-oriented world. And you construct, concept number three is you construct very rich user interfaces by creating components and then embedding other components inside that particular parent component. So what do I mean by letting React manage the DOM? Let's assume for a moment that you've got a very basic website, a HTML file. It's got a H1 block and it's got a div. React will not touch your website unless you ask it to do so. And the way you ask it to do so is you create a particular element such as a div. You give it a particular ID, and then in your JavaScript file, you run the command react-dom.render, and you actually point that to the div in your HTML file that you want React to manage. For example, as you can see here, you can see that you're basically, actually I'm going to end my experiment. It's not working. Okay, so basically use document.getElementById, which is a normal JavaScript function that you're aware of. It's part of the document object. And you're basically obtaining the actual div element in your HTML file by using the tag, and you're instructing React to manage it. You're telling that anything inside the div tags, it's going to take care of. Okay, that's concept number one. Don't worry about the const element equals H1. That's essentially the React component. It's a bit of what's called JSX, but don't worry about that for now. So that's essentially concept number one to understanding React. Concept number two is React works by creating a component, which is a blueprint to the visual object that you will see. Think of a component as like a maths function. You basically, the results of the function, so let's say you got a maths function like y equals x plus z, where y is the output, is the result. The result of the function is dependent on x plus z. Okay? When it comes to React, the actual component, the actual result that you visually see is based on what's called the state and the prop, which we will actually in the working demonstration learn and see how it works. That's what you eventually see. Props are basically data you pass in externally, because if you remember, I said that, for example, when you create React components, you create subcomponents. Those subcomponents could have subcomponents, and they all need and each component is designed to only take care of its own individual concern. But obviously they need to communicate, and they don't communicate directly. They communicate by passing data from a parent component to a child component via the props. Each component can also have a state which it manages itself, but you can provide an initial seed for it. And together, based on the props that you feed into a component and the component's own inner state, that is what you combine to produce the actual output. But that might sound confusing, so we'll just have a look at an example. So, for example, this is a very simple component that we're going to make. The component is called hello, and the render function that is part of the hello component is the most important component in React, in a React component. What the render function returns is in fact the HTML that is shown to the user. It's not technically HTML, but just assume it is for now. So in this example, for example, we have a component called hello, and it's returning a h1 tag with hello text, and then inside the squiggly bracket, which means interpret what's inside as JavaScript rather than as a string. This.props.message means that this component expects you to pass in a message, a variable, as a prop, and then this command, this.props, the message will be able to extract, will be able to obtain that message file data, and that's what's going to get returned. The final bit is where you actually tell React. So this is not part of the component, but it's equally important. In fact, probably more important. This is what actually attaches this component to the actual DOM that you're actually looking at, right? Yeah, that the user actually sees. For example, the component is called hello. Component is called hello, as you can see at the top. Now, you can see here React DOM.render, which you saw 2 slides ago. It's actually saying it's actually telling React to control the root element. So let's say your HTML file has a div with ID called root. This command is actually telling React, okay, manage that particular div, which has an ID of root, and fill it up with the hello component. By having said that, pass in a property called message, which, mind you, is what you actually receive when you type in this.props.message. And whatever you type in here, which is, for example, a string called my friend, that is what this thing here will end up being. So it's quite, once you understand this might sound a bit complicated when you are used to dealing with jQuery, but once you understand this, it's actually quite simple. Now, concept number 3 that is essential to understanding React is you have to think of your user interface as, you have to think of it as a component that is a parent component with sub-components inside. For example, and this is crucial, in fact, you will not be able to do any React development unless you keep thinking in terms of how can so whatever your user interface is that you want to build, how can I split it up into natural sub-components that make sense in its own right? This is from Facebook's tutorial called Thinking in React, for example. Let's say, for example, you had a user interface and this is the end result you would like to have. That's what you want the user to eventually see. What they are suggesting is, okay, what's a natural way of separating this particular user interface so that, what's a natural way of splitting up the user interface so that each individual subcomponent naturally can take care of its own, displaying its own content. That is a logical thing that's very simple for it to show. So what they've done is, okay, they've said, okay, so this is the end user interface that you want to create for the user. They are suggesting the search box at the top is a very good subcomponent that deserves to be its own subcomponent. Therefore, you can split it up, and that'll be one component. The green bit here is some kind of parent component that seems to hold a whole lot of subcomponents inside, including, so for maybe in a table, for example, maybe these are two column headings or something like that. And it seems to have two different types of subcomponents inside. One of them is the blue one, which might be a header of some sort, and actual individual subcomponents, which are rows, which obviously display some kind of title and a price. So maybe that'll be two prompts that this particular subcomponent will receive. You give it a text and you give it a price. You use the same subcomponent, so think of it as a class that you're reusing. Use the same subcomponent in this example, 3 different occasions at the top and 3 different occasions at the bottom, and they all behave exactly the same except for the fact that you provide 2 different variables. You provide 2 different variables and it'll appropriately display the data in line with the variables that you pass in the prompts. Now, obviously this is a Go Meetup. Now I've created a package called Rocket Launcher /React. This is something I made. It's not part of the company I work for. So don't judge it if you see it and you see a bug. It's not the quality of OpenSimpson's work. This is my work. It's a very, very thin wrapper over React.js's API. Very thin. And the reason why I created it was the #1 React bindings for Go is the one at the bottom, which is my itcbo.io/React. This one got a lot of airtime in GopherCon UK a couple of years ago, and because of that, it exploded in popularity. But in my opinion, it was not ready for real-time production usage. It didn't give you access to all the styles that you would like to change, and it also didn't give you access to all the attributes. And the guy is too busy. The guy who maintains it too busy. So if you do a pull request, which I did, to try and include these features, he's like, I'll have a look at it in a month, and you ask again in a month, and he goes, yeah, I'll have a look at it in another month, and he just keeps going, and he's not interested. Therefore, I had no alternative but to make my own, which is doesn't try to do any magic like this one does. He uses GoGenerate, which he felt was a very beneficial thing to do, but in my opinion, it was just very, very cumbersome. It slowed down development. There's another one as well called BEP/GR, but that doesn't seem to be maintained. So I don't recommend it. So let's now work on the project. Let's work on a little demonstration project, which is probably more interesting. Okay, so we have here a standard a standard Electron application. I'm not going to be programming for a web browser today because every backend developer fears Webpack, and I didn't want to embarrass myself. So I'm just using I'm using Electron, which is basically, as I mentioned, a Chromium-based browser. It's a browser, but it's for making desktop applications, and for all intents and purposes, this is a desktop application, but just assume it's a website. Just assume it's a website. Okay, so this is what the aim of this tutorial will be to try and create this user interface. As you can see, there are a couple of subcomponents. So in React, you have to first visualize what you want to achieve and what you want to provide to the user. And then you've got to try and think about natural logical subcomponents that make sense and simplify your project down into a more manageable level. So when you look at this, you can see there's a heading called events handling. You can see there's a counter which seems to be done. So the events handling bit at the top is static. Okay, so maybe that's one component. It can be static, that's fine. There seems to be another piece of text at the bottom, but that seems to be, it seems to not be static. When you click on the add button, it seems to increment that counter based on the HTML5 range slider, the value that the slider has. There seems to also be a slider which allows the user to move it left and right, which changes the text in the add button, and the add button itself seems to be the final thing that actually increments the counter when you press it. So it's a very, very simple user interface. and we'll try and split it up into logical bits. Okay, so the way I split it up, there's obviously numerous ways of doing this. There's absolutely numerous ways of doing this. The way I split it up is, I split it up into two parts. So the title is, yeah. So the title is, so you can do it numerous ways. You have freedom to do, split up your subcomponents however you want, but in my example, I'll be treating this as a very simple static component that doesn't, the output is not dependent on the state or the property, and that makes sense, so it's just a basic label. But then this bit here, I'll be treating it as an actual component in its own right. Maybe you could have split it up into 2 or 3 parts yourself, but I didn't do that. So that's the aim for today. So this here is a standard, Chromium. This is basically when you download Chromium and you run it, this is all you get from the Hello World project that you get. You get a HTML file that's index.html, and you'll get a main.js file, which is not the concern for today. This is, so if you, Chromium is basically, although it's you program in JavaScript, it's not the same JavaScript. One half of it is done in Node.js, and this is the Node.js stuff, which we won't be, that's got nothing to do with React. But having said that, with Gopher.js, you can also program your, it's called the, what process is? The main process. So the main process is basically Node.js, and you can program that in Gopher.js, but that's not React-based, so I'm not going to be dealing with that. So you get an index.html is what's called the render process, which is basically what you actually see inside the Chromium window, which is essentially a web browser for all intents and purposes. Okay, so step 1 is we will create a div because we would like React to manage a particular section of our code. We would like React to manage it. Therefore, we need to create a div. Step 2 is we want to use some JavaScript. So right now, let's get rid of it. This will be empty. It's not, but I'll make it empty. Okay, so we have a basic website and a JavaScript. We have a JavaScript file. Now let's run it. So Gopher.js is basically the command Gopher.js is essentially similar to your Go command. So when you want to compile in Go, you write Go build. When you want to compile using Gopher.js, it accepts almost the same arguments. You just you have to first install Gopher.js, and you just write Gopher.js build. Unlike the normal Go file, that normal Go command, it doesn't generate a standalone executable file. It will generate JavaScript, which I have called tutorial.js, which is what you saw in here. So if I was to run it, it probably won't work because there's no actual code. Okay, maybe there is something. No, it's empty. So there's no actual JavaScript. So let's try and now start making something. Okay, the next thing is we need to include Facebook's React library. These three. This is basically just an npm package.json file. I'm just basically saying I need React. I need React DOM. And I need create React class, which is necessary for my library, for my package. Now, because I'm not using Webpack or any of these fancy bundlers, I do need to also create another JS file, which is part of Gopher.js. So Gopher.js will understand that if you have an inc.js file, you can basically include basically npm packages in there. However, it doesn't actually bundle them up into a standalone JavaScript file. If you want to do that, you need to use, once again, Webpack or some other bundling program like that, but I'm scared of Webpack, so we're not using it. We're just doing this. Okay, so let's start with the project. So this is a very simple project. Oops. First things first, I think I mentioned that the easiest, let's start off with the very first subcomponent in our project, which is going to be the events handling title component. Okay, so what we will do is this. Forget about this for now. We will create a brand new file. Package main. What did I call it? Oops, what just happened? What did I save it as? Did I save it? Yeah, I did. Okay. So this is how you make a very, very basic component in React. Now I'll explain what's going on. So a lot of the stuff here is related to the way my package works. Okay, so that's my rocket launcher / React package. So the first line is this. So to make this title component, first we need to, so this is just boilerplate stuff. You don't even need to know how it works or why it's done this way. You just do it this way and you just don't question it. We create a title component object. This is part of the Gopher.js object package, which is part of Gopher.js, which is basically, it's basically the JS object is in fact a Go object, the Go struct that gets converted to a JavaScript object when Gopher.js creates JavaScript files. So that's essentially what a JS object is. I create a variable at the top called title component, and the very last line is just setting the variable. React.create class, so basically creating a class using my library, but you need to give a definition of how the component operates. So that's the next bit. We first create a class definition using this command, react.newClassDef, and you can call it whatever you want. I just called it title. It doesn't get rendered. This is in fact for the purpose of debugging, this little stringlet you add, because when you actually run your React project, you need to, generally speaking, install the React Developer plugin, which allows you to basically perform some diagnostic, get some diagnostic information about your React project. But if you don't give it a name, React will give it a random name for you, and you won't be able to identify your objects to help you fix up your bugs. So you have to give it a name here. The render method is the most important method. So this is where you define what actually visually gets shown to the user. It's equivalent to, if you look, the JavaScript that we showed here. It's essentially, so what I'm attempting to do in Go is, using my package, it's basically this process here where it's render and you return some JSX. That's essentially the equivalent thing you're trying to do here. Basically, you created your definition, which I've called title def. I then create a render method, so that's equivalent to it's equivalent to this render method in JavaScript, which is if you're looking at JavaScript tutorials and examples and how to do stuff, that's what you'll see on the websites. We're creating a variable. We're creating a variable called title, which is coming from a prop, which I'll explain soon. But more importantly, we're then returning a h1 object, which will end up being, I guess, similar to the h1 that you're seeing here. We're creating a h1 object using an element sub-package that's also part of my package. You pass in a particular, you pass in some properties to the h1 package that will allow basically some CSS styling. So I'm just saying I want this particular h1 to be styled to the text align in the center. And then more importantly, you pass in the child data for the h1 object, which is equivalent to, I guess, the stuff inside here. But in my case, I'm actually creating a title string, and the title string itself will have the full contents of what will be in the h1 component. Now for the props, which is one of the most important things. So if you remember, a React component is a function that what you see is a function of both properties and the state. It is a function of both the state and the property. So in this particular occasion, I'm actually creating a property called title props. This property will have one field called title, which will be a string. When I set this prop and pass it into my component, then the render function in my component will extract it using this command here. So it's basically equivalent to unmarshalling. That's what this is. I just called it hydrate because I thought it sounded better. But it's essentially, maybe I should have called it unmarshal, which is more in line with Go terminology. So basically, I've created an empty title prop. But right now though, I've just created an empty prop. It doesn't actually contain the title that you pass into it. So I need to hydrate it so that it has whatever title I feed into it, and it'll fill up the variable. Then I can create a variable tprops.title, and then I can pass that in as the child data for my h1 element. As you can see. Now at this stage, it's not going to do anything because a component is just a blueprint. It doesn't actually exist. It's just a blueprint, so we need to make it exist. So now we'll go back into our Go file, into our main Go file, which is like the main file in Go. You create a package main, and then you create a function main, and this is the entry point for your JavaScript. It's for your Go application, exactly the same process. First of all, there's a package called go/js/dom, which allows you to manipulate and query the DOM. In our case, if you remember, I created a div called with an ID of app, and I'm going to ask React to take care of it, manage it for me. That's essentially what I'm going to do. Right now, it's just in the HTML file. It's just a standard div. It doesn't do anything unless I tell React to start managing it and doing stuff there. So what I'm going to do is this package is used to obtain a reference to that particular node in the DOM. You can see the app, which is a reference to this ID here. I will now call this command here, which will basically say, it's basically going to tell React to mount, it's called mounting, that's the terminology, mount your component which you just created, and you called it title component, as you can see here. You create a title component. I'm going to ask React to actually mount my title component. Okay, there's another step involved, which is going to complicate it. Okay, I see. Okay, this is going to complicate. I'm sorry about this. So React also has what's called a functional component. If your component is not going to be a function of both the state and the props, which is what I said, I said that a component in React is the output that it produces is a function of the props and the state. If it's not going to have any state, you can actually create a component that is much simpler to create, where you don't need to make it like a class, and that's called a functional component, which is only going to be a function of the props. And in this particular case, I actually created another component called container, which will contain both the component at the top, this one here, and this component here, which I said are the two subcomponents, but it will actually contain both of them inside, so it's a parent container. So it's an extra slight complexity. And all it does is, as you can see here, all it does is it'll pass in a title. Something right here. Why is that? Okay, so so basically this particular container, this container component, which is a functional component, it accepts a property of itself, which is called container prop, which just holds the title value. I pass in a container, I pass in that particular container prop with the text title, which is just statically typed. I just defined it as event handling. I pass it into the container. I then ask it to be mounted to the DOM target, which is the div with the app on it, which is with the ID app. And then that will have some effect. So let's have a look at it. Okay, let's run the Electron project again. It's okay, something's not right. What is going on? Element. Tutorial, go, render, compile. Title component. Okay. Sorry about that. It's not the same. Okay, so let's run this again. Oh no, I hate this. I hate when this happens.
How come you're compiling to the subdirectory on top?
Am I?
When you go dot dot.
Ah, shit. Okay, yeah, you got it. Okay, you solved it. Thank you. Okay, so that is the little component that we created. Doesn't do anything special, but that's the component we created. I'll just go back to the HTML and get rid of the stuff at the top. We'll get rid of this as well. How much time do I have, Leah? I don't seem to have. I seem to be taking a lot of. How much time do I have? Sorry?
Whatever you want.
Oh, okay.
Yeah, I think
Okay.
Yeah.
Okay. Okay, I understand. I get the message. Okay. So that's the first bit. Let's quickly create the bottom bit, which is the second component.
Why did you do it?
Sorry, what?
Why?
Do what?
This.
Do what? I mean, my project, or?
Yeah. Why?
Well, it's for a leaf.
Different, but why?
Well, I wanted to, that's why.
Okay.
I mean,
Alright.
okay, so let's get this. I'll quickly just, rather than doing it live, I'll just copy it and explain it.
Is this in JSX worth the extra complexity?
Sorry?
Is the extra complexity worth losing JSX?
It's actually, JSX is actually a controversial topic even amongst JavaScript developers who use React. It's actually not as helpful as people think it is. And
Right. I know the opposite opinion.
sorry? Well, the whole project, if you already know front-end development and you're trying to make a website, you will not use Go4JS under any circumstances. The file sizes are simply too big.
Yeah.
Okay, but if you don't, or you're trying to make an Electron application, and you don't know JavaScript, just plain old JavaScript, then this is Go4JS is an amazing project. So let's just, I've just created a new one, which I'll run through without actually doing it live. But let me, let's just see if it works. Yes, it does. Okay, cool. Okay, so that's the end result. I don't have any style sheets here, whereas with my example I did. But okay, so what I did was I created another subcomponent called events component, and this particular component I created purely because this also has state, whereas the previous one just relied on the properties. This one relies on both properties and state. And the state that it relies on is, so first I create a struct, and the state that I rely on is counter. It's an integer, and it basically keeps track of the number that you see. It keeps track of that number there. I have another state. It doesn't have to be done via a state, but I did it through a state. I did it as a state variable, but the slider value, which will record once you move it, the brand new slider value. It didn't have to be done that way. There are other ways of doing it, but that's how I did it. So for this particular example, I created an initial seed. So if you remember, a state is basically the component's internal data memory, but you can give it an initial seed. And you do that by using the getInitialState method, where I basically seed it, in my case, I seed it with a counter value of 0 and a slider value of 0. So this is the state, and this is the initial state. I'm not going to go into, due to lack of time, I'm not going to go into component did mount. But basically this, in order to properly deal with the slider, you need to get a reference to it. But I'm not going to deal with that. I'm not going to discuss that. Okay. Okay, we'll go to the most important part, which is the render function once again. But in this particular case, you'll see that it, unlike before, where it was just dependent on the props. In this particular case, I am dependent on the state, which has slider value, which, if you remember, is this one here at the top. So that's one of the items in this state, and the struct tag is how you can extract that value. So one is slider value, which is used to It's used in two places, as you can see. One is to actually display the title, the text in the button. So this one here. So as you move this slider, it changes a state, which is something I haven't discussed in here, which is the change. So the change is fired when you move the slider, and I update the state with the brand new value from the slider. But once it's updated, React will take care of automatically refiring the render function. And in my particular case, I update the text that's in the button. And that's what you see here. You can see here button text. You'll see here this is the JSX part, which a member of the audience mentioned. So this is essentially JSX. One is a div. Inside the div is a H3, an input, and a button. So this is the way of doing JSX in my package. And the button text is from this variable here. Obviously, you need to also detect when the button is pressed. So you basically, for the button that you created, so the button is created here, you pass in an on-click, you pass in a property that has an on-click field that will attach itself to a click handler, which I defined here, which will take care of updating the state when the button gets clicked. I'm not going to discuss that, but essentially that's what it is. And the end result is you can, I've written a tutorial which you can find, which you can go to medium.com/@rocketlauncher.cloud, and you will see here, go with React, and it'll explain how to use my package. But I'll essentially, I gave you a basic introduction to Gopher.js, basic introduction to React if you hadn't already interacted with it, and creating a couple of quick components using my package, which will allow you to create rich user interfaces in Electron or on a website if you want to. So I'll coordinate. So thank you very much.
Any more questions? Yeah, great.
Why do you hydrate the props from this object instead of the props object that gets passed into render?
Sorry, what?
So the render method seems to have a props object as well, but you were hydrating.
Oh, yeah, I understand what you're saying. So if you go to the render object, this is a convenience. So I've created a convenience map where you can obtain the props and the state by using it like this.
Right.
However, when you do it this way, you lose the type information.
Yeah, exactly.
So you've got to already know that, okay, the slider value is an int, for example, and you've got to...
also, if you mistype that, you don't, the compiler won't type.
That's correct. So you lose the type information, which is why an alternative that you can use is the hydrate. For example, you can do something like this. I was just demonstrating two different ways in my package.
Right, so you can't hydrate from the props, but you can hydrate from this.
No. You can hydrate from the props and the state.
Okay.
Alternatively, you can use the helper function that comes in the signature of the argument.
Yeah.
But when you do that, when you use these two, then you lose the type information.
Oh, those are functions. I see.
It's a map. It's essentially a map. It's a function that behind the scenes is a map.
Yeah.
And that's how you get the value out of it.
That makes a lot more sense.
And yeah. Is there any other questions? Yeah.
What did you find testing? Unit testing?
No, there's no unit testing. It's very difficult to unit test React applications. I've seen a couple of packages in the React universe for unit testing React components, and it's not easy.
But this Go.
No, it doesn't matter. In the end of the day, the Go stuff in here is trivial. The actual Go code is very trivial in how the package works. It's a very, very thin wrapper around the React API. Very, very thin. So,
are you going to create something like a Redux to manage the state?
I don't. Obviously, for people who don't know about React and Vue, although this is a major improvement over jQuery, React and Vue, when you're making even larger scale applications, you do need to worry about state management. And every 6 months, there seems to be a brand new way of doing it, a brand new library in Java for state management, like Redux or I think MobX or whatever. There's so many of them. Every 6 months, a new one comes up. That in itself is very complicated, and I haven't even looked at creating a Go version, making a package that would interact with it. It can be done. Maybe someone else can do it, but I didn't have time.
Are you using any of this in production? Or?
No, this is a personal project, so this is not related to OpenSimSim, which is the company I work for. In fact, the company I work for, we use Angular.
Really?
Yeah, that's right. This is a personal project, but I am working on something for production right now. What's your, yep?
You guys should show us the output of JS tutorial.
Oh, yep, good. Okay, so you want to see how big it is. Okay. So this has not been minimized. Okay, so let's have a look at it minimized. Okay, so this is unminimized, and the file size is 2.2 meg. But now I'll compile it minimized. It's shrunk to 1.5. So it's still, as I said, it's very large. It's not appropriate for a website. You can get it even smaller, but you have to get rid of packages that use funct and HTTP. You have to also use that CDN, which I mentioned, which will store the standard library packages in the cloud, so that everyone who uses Go4JS can all share it, and therefore you don't have to download it. That can shrink it significantly. You can also, in your web server, also set up what is that compression? gzip. That will actually compress it significantly, but in the end, it'll compress it to very respectable levels. But in the end of the day, although it's gzipped and it is shrunken to a very respectable level, in the end of the day, when it's uncompressed by the browser, by the JavaScript engine, it's still going to be very, very big. So it's not going to. Sure, it means it's going to download quite easily, but it's still a very large JavaScript file that the Chrome's V8 engine is going to be interpreting.
Can you use Go-routine?
Yep. Go4JS. I don't know how it works when it gets compiled to JavaScript, but Go routines work just fine. But obviously, there is no concurrency in the JavaScript. So there's no multi-threading. So there is concurrency with Go routines, but there's no multi-threading. Therefore, it's not actually utilizing the excess cores in your CPU. But it'll work just fine. Any other questions?
I have 2 questions, if I can.
Yeah.
The first one is related to the file size. The question is, how does it scale? So if you...
Okay, that's a good question. As you guys are Go developers, I'm pretty sure you guys have created a Hello World project in Go and seen the file size. It's how much. Does anyone know what it is? I'm not sure what it is. It's like, is it 5 megs for like a simple, 6 megs for a simple Hello World? The same reason why the Hello World project in a standalone Go application is so large is the same reason why the JavaScript generated by Go4JS is so large, because the standard library, the Go runtime, it all has to get packed into the JavaScript file. But in terms of how much it scales, so as your program gets bigger, it actually scales quite well. It doesn't, the big chunk of the file size is due to the Go runtime being converted to JavaScript. No different from the standalone Go application. So what's the next question?
The next question is related to the Go routines. So if you have 2 Go routines in your code,
Yeah.
which communicate with each other through
It'll work. I don't know how, but it works.
Okay, so theoretically it is possible, I think, please answer this, theoretically it's possible that the 2 channels block each other in JavaScript while they are undefined in Go. Is it possible?
No, it will be a bug in the Go4JS project if that's the case. In fact, I'll show.
There's a limitation somewhere.
I'll show you. So there is there are some what you explain will work fine, but you have to be, in terms of the Go routine communicating with callbacks in objects in your DOM, there are some special precautions because JavaScript is non-blocking. So you have to make sure that it's not blocking the way you do it, but that's not related to the question. What you mentioned will work fine. I'll just also show you before, unless there's any more questions, I'll just show you something. Fine. Compatibility table. So this is a table that explains in the standard library what is supported by the Go4JS project, and almost everything is supported. Almost everything. And most stuff that aren't supported are stuff that's directly related to interacting with the hardware, or stuff that the sandbox environment in your browser will not allow you to escape from. That's 99% of the stuff that's not compatible with Go4JS is related to that. Any other questions before I finish up? Okay, well, thank you very much.